Hey, doing? So, this is not necessarily a tutorial. This is just how I've done things. So, I'm kind of showing you what I've done in my game Cannon Blaster, and you've seen all the different aspects of it. And this first episode of that is going to be setting up the environment. So, what I assume from you is that you have Visual Studio Code, Visual Studio Code, and that you have Pygame already installed. If you don't, you would just do pip install Pygame. I already have it installed, but that's what you would type. And then once you're in Visual Studio Code, we're going to import the Pygame module. And so you can just import it that way. We can also import it as something. In case you don't want to keep typing Pygame a lot, we can do import Pygame as PG. So then when we go down to initialize Pygame, which will come up, later if you don't do it sooner. So I always just do it sooner anyway. So you would do PG dot init and then there. And that would initialize it. However, if you don't want to import Pygame as PG, if we do that, then you would have to type Pygame. So we're going to just stick with that. That's just something you can know. So we want to create a screen, and this isn't going to do that. In fact, if you just press F5 to run, you're going to get hello from the Pygame community because we've initialized Pygame. I believe that only happens from the initial. Nope. Apparently it's from importing. Okay. But anyway, let's, we've tested that kind of stuff. So now we want a screen, and we need to know how big of a screen. So we just need to set some dimensions. So you can do this with two variables here. These will be constants. And I like to do things that are related to each other on the same line. So width and height will be, let's do 1280 by 720. And so now that we have our dimensions, those mean nothing right now unless we try to use them. So we want to create a screen. And the way that you do that is you don't really interface with the screen directly. You create an object for the screen, and then you interface with that object. Well, I'm going to create one called screen, because I'm highly original. And now we're going to assign that pygame.display and then set mode right there. Now, take a look at this. So this is telling you all the things that you can do with it, and it shows you the data type that is going to be the output, which is the data type will be a surface. Surfaces are basically like an invisible canvas. And then when you put things on them, they stay within the confines of the canvas. In this case, this is the screen, so it's going to be the entire screen. Note that from here, which is this, to here, which is this, there are coordinates, which are also in parentheses. So if we wanted to create a screen of this width and this height, if we go ahead and just paste that straight in there, we're not going to be getting what we need, because this side of the comma is flags, because that's this comma. The way that we get to use this comma is we need to make this a tuple. That was weird. So here we are. And I know it looks strange having like double parentheses, but this is just this whole tuple of two things is the first element for the screen. And so now we're ready to fire it up because we've created a screen. And there it is. And there it goes. So that's gone just as quickly as we saw it because the only way that we need, the only way that we can keep it here is if it's part of a loop. A loop that does not end, which is what basically game loops are. Games are programs that do not finish executing until you're done playing, which seems a bit obvious. But, you know, if you were to run a program to, say, calculate the difference between Fahrenheit and Celsius, you would start the program, it would run through all its things, you type in Celsius, and it's like, okay, well then here's the output. You know, 10 Celsius is 50 Fahrenheit, for instance. Then it ends. You know, if you wanted to get more elaborate with that, you could be like, do you want to do another one? And then you could have it say yes or no. And then if you say yes, then it loops back around again. That's what basically games are. You know, the main menu, the game element, the game over, the loop back. So we need to create a loop. And we can do that easily with while. So if we do while true, which would be always true, so everything that happens will always happen between, you know, this indent, this while loop will go on forever because true will never change. And then we want to have a way of getting out of this loop, don't we? So let's go down one more, and now let's check Pygame for all the events that can happen. And events are like clicking things, mouse button, mouse moving, keyboard presses, all that stuff. So we also want to loop through all of those. So we want to check every event. So whenever we find an event, we want to store that event as the name event. So for every event in Pygame event get, so the event get is a method. So it's going to get the events. So we're gonna loop through all the possible events that can happen within Pygame, and we're gonna each one is going to be stored in event. So now if we say if event type, because a Pygame event get has lots of different methods in it as well. So we're looking at the event type. And if that's comparable to Pygame quit, which is the act of clicking the X in the top right hand of the screen, then we want Pygame to quit, which is also a method. Then we want to exit, which is, again, a method. So now if we run this, the window stays open. Move it around. Probably didn't want to do that. And if we click this, boom, it's gone. So not only can you do like, clicking that X, we can also check for a different kind of event. So if event.type, it's comparable to Pygame.keyDown. So if you press a key down, now what key? Well, we can check for that too. If event.key is equal to or comparable to pygame.key underscore escape. So if we press escape, we will do the same thing. Oh, got to indent that one more time. Okay. So now, if we do this again, we can click the X. We do this again, we can press escape. And it's gone. You can also do other things like set the full screen. So while we're checking for key downs, we could say if event.key is comparable to, and another way of doing things, because we could do pygame.k underscore f, but we can also do, ORD F. So if we press F, then we can do pygame.display toggle full screen. And that's a method. So we have to do that. So now if we are here, we can press F. And if you had the dimensions correct, you would not have this crap going on. But if you press F again, then yeah, you come back. So, and then we can escape. Now, we can also do things with this window like displaying the frames per second, which is going to be important because if you're going to be making a game and you want the game to run at the same speed at all frames, that all frame rates, we're going to have to include what is called delta time, which we will come into in a future video. But you will want to be able to see what kind of frame rate you have. Also, it can help you find out if you're doing things that are like CPU intensive and you don't realize that you are. It's nice to just see the frame rate. So for us to see the frame rate, we're going to need a clock. And Pygame comes with its own clock. And so in the same respect as the screen, we want to set a clock object. Pygame.time.clock with a capital C. If you do it with a lowercase c, it's not going to like you. So let's go ahead and do that. Yeah. Module Pygame time has no attribute clock. It's quite pedantic. So now we have, oh, no, I should have seen that coming, shouldn't I? Clock, there we go. Yeah. Of course, we can't see what the clock is showing. So we want to do something like this. So in the game loop, we want to, every time we go through the loop, we want it to update the caption that is the top of the screen. So if we do pygame.display set not mode, set caption. And the caption has to be a string. So we could do like Pygame caption. So if we do that, then it says Pygame caption. So we want to replace that with the frame rate. And the way that you get the frame rate is by clock get frames per second, which is a method. And so if we do this, it's going to error. And it says argument 1 must be a string, not a float. So this is a float, but we can't make a float a a caption because it's not a string. So we just convert it into a string. And now we get to see the frames per second, which are 0 right now because we are not actually doing anything to get that. We need to do some sort of frame limiting, even if that frame limiting is, saying 0. So every time we loop, we want the clock to tick, and we can set that to 60 frames. So this is going to limit the clock, the frame rate to 60 frames per second. So if we do this, now we're going to see up here in the top left our frame rate with a whole bunch of decimals after it. We can refine that even better. We can like round that to maybe 0 decimal places. And there we go. Now it's freaking out around about 60 frames per second. But what if we set this to 0 frames per second? How many frames are we going to get that way? Wow, cannot convert float infinity to integer. That's interesting. I didn't expect that. All right, so let's give this like 2 decimal places. And there we go. So we're doing 10,000 frames per second. My mouse is delayed because the only thing we're doing is drawing the screen, but that's about it. So yeah, that is how we will get our screen set up. Everything else we do will be done on top of this. So this is our game loop here. So that's our game loop. And the rest of this is just basically these are our constants. And these are our objects, I guess. And so yeah, in future videos, now that we've got this set up, we're going to create basically objects like the spaceship, and control it around the screen and do things with that. But we couldn't do any of that unless we got this set up first. So yeah, if you liked what you see, go ahead, subscribe, like, helps me out. Helps these videos get out there. So yeah, bye.